in this problem we have to divide this interval 0 to pi by 2. Let me use it. So interval is 0 to pi by 2 and the function is root cos x, and the methodology of the procedure is Simpson's 1/3 rule. Here one important point you need to remember, they mentioned the number of points, not the number of subintervals. Usually when you divide into, let me go through later. First write the given data in this. A is 0 and B is pi by 2 or 90 degrees. The number of subintervals, when there are 7 points, say for example if you have a 2 subintervals, then the number of points are going to be 3. 1, 2, 3. The number of subintervals are 2, points are 3. That means points are always 1 more than the number of subintervals. So here there are 7 points. That means the number of subintervals are going to be less by 1. That means 6 subintervals you will get it. Always number of subintervals is lesser by 1 point in terms of ordinates. Let's take this example. When you have 2 subintervals, you get the 3 points. That means the number of subintervals is less by 1. Now the function is root cos x or root cos theta, doesn't matter. Now we have to calculate the step size h, which is b minus a by n. In this case 90 degrees minus 0 divided by 6 subintervals, so approximately you'll get it as 15 degrees. Now let me see the points and the corresponding x values. So these are the x values and these are y is equals to f of x or root cos x values we need to compute. Now the initial or the starting value is the lower limit of the integral, which is 0, and the upper limit of the integral is 90, which is b. So therefore this a value is 0 and this is 90 degrees. As we know, step size is 15. Continuously add this step size h. 15 plus 15 30, 30 plus 15 degrees 45 degrees, next 15 degrees 60, next 75 degrees, next 75 plus 15. You're going to get the last point, that is upper limit of the integral, which is 90. Now at this values of x, we need to calculate the root cos x value, that is root cos 0 value, which is 1. Similarly root cos 15 you calculate in calculator and make sure that the calculator is in degrees mode if you are using degree mode calculation, or if you're using radian mode then set the calculator into radians mode, but I am using degrees mode. I'll set the calculator in degrees mode before computing this. Similarly cos 30 degrees, and let me write this first. Now if you use scientific calculator, the values at this points are going to be, this is 0.9628, 0.9306, 9306, next value 0.8409, check out with your calculators, 0.8409, 0.7071, 0.5087, and the last value cos 90, which is 1, root 1 is 1. These are the y values. Let me indicate with the index. This is y0, y1, y2, this is y3, y4, y5 and y6. Total 7 points. Starting from y0 to y6 we have total 7 points. Now in the problem we are supposed to apply Simpson's 1/3. Okay, so we have to use a Simpson's 1/3 rule. So for Simpson's 1/3 rule, easily can remember the formula in this pattern, then you can write it for your question. So this comes as h by 3 first y value plus last y value. In this case it is going to be y0 plus y6 plus 2 times of even y indices, which is y2 plus y4. I'm not going to write y6, observe, because y6 is already included in the first one, because y6 is the last term. 4 times of remaining values, which are y1, y3 and y5. Remaining y values in sense which are not listed in the first two component, like y0 plus y6 as well as y2 plus y4. So now substitute the values, that is y1, y3, whatever the values we have in the previous table. Substitute all the values. We have the values in the table. See, substitute all these values and simplify component wise. Your approximate value is going to be 1.1873. After substituting and simplification, it comes as 1.1873.